Welcome to solverfy.
Looking at these structures, we see that there are functional groups attached here, so that we have to pay attention to make sure we know exactly what we are putting with these carbon chains. So the first one is formaldehyde, which is also known as methanal. So it's meth with an AL at the end, methanal. That is going to have that double bonded oxygen there, right? So it's methanol, or it's methanal, right? So meth just being, let's try that again. Meth just being that one carbon chain with a double bonded oxygen. Remember, carbon needs 4 bonds, so the other 2 bonds attached will be hydrogen. Right. On the next one, we have a 4-heptanone. So heptanone is going to be a 7 carbon chain, and we have that ketone, so we have that double bonded oxygen there. So it's going to be a 7 carbon chain with the appropriate hydrogens attached with the oxygen on carbon number 4. Right. So if we write this in our line structure, it's a little faster. So it's 2, 3, 4, 5, 6, 7 is our total structure. Remember, the hydrogens are assumed here. Each point is a carbon. So if we number this as carbon number 1, right? So 1, 2, 3, carbon number 4 has the double bonded oxygen there. Okay, so that carbon would not have any other hydrogens on it, but the rest of the carbons will have the appropriate number of hydrogens. For 3-chlorobutanol, remember that Al means that we have that double bonded oxygen on the first carbon. It doesn't specifically need a number because that's what the Al implies. So it's the butane, okay? So a butane is a 4-carbon compound. So 1, 2, 3, 4, right? We could also write this including our, with our line diagram, but we're just gonna do it this way for now. So if we call this carbon 1, that gets our double bonded oxygen with 1 hydrogen to fill up the bonds, right? We have hydrogen, hydrogen, and then the chlorine is on carbon 3, so 3-chloro, right? We fill in the rest of the hydrogens just to make the bonds all correct. Last one is 5,5-dimethyl 2-hexanone. So hex is going to be a 6-carbon chain. Okay, so if we do the line structure here, it's 2, 3, 4, 5, 6. So the first one's a CH3. We know that the ketone is on carbon number 2, so we'll call this carbon number 2. And then we have 5,5-dimethyl. Right, so 1, 2, 3, 4. So 5,5-dimethyl means we have 2 CH3 groups coming off that 5th carbon.